Hello, everyone. This lesson is on an example on sketching the graph of a specific function. But this function that we have selected is trigonometry-related functions. In this lesson, I'm going to assume that most of you, or at least some of you, have not learned or not learning enough of trigonometry. So I'm going to bring the contents of trigonometry to show you how the crash course the recorded lesson I made for you can be used here for solving questions like this. Okay, there will be multiple places that we need to use the knowledge of trigonometry. But in those cases, and I will go into details, I'll go in more depth as how to apply the trigonometry knowledge that we have introduced to you. Okay, so first of all, on domain, okay, obviously we have a denominator here. We have a denominator here, right? So what will be the domain of the function? As we understand that from our crash course of trigonometry, we know that cosine x and sine x alone, their domain are all real numbers. But when we have an operation on them, we have a 2 plus sine x in the denominator and cosine x in the numerator. The numerator, obviously, x can be any real number, but how about the denominator? How do we guarantee the denominator is going to be, not equal to 0? Right? So obviously we need to make sure that's going to be guaranteed. But in this case, because we know the domain of sine, okay, is between -1 and +1, right? So 2 plus sine will always be positive, okay? So here I'm going to give you some reason, okay? So since this is the range for sine, okay, for any real number x, okay, for any real number x, the domain of sine is all real numbers, and the range is from -1 to +1. Therefore, 2 plus sine x is always positive, so it's guaranteed. So this will be true for any real number. This basically tells us the domain for this function, for the given function, is going to be all real numbers. All real numbers. Okay, so this is how we use the knowledge we learn about domain and range for sine and cosine here. Okay, the second question, intercepts. Intercepts. Intercepts, once again, we're going to find y-intercept first, right? We're going to find y-intercept first. So let's first find y-intercept. By find y-intercept, we set x equals 0. So we're going to set x equals to 0. Okay, so all the x will be substituted by 0, sine 0. Okay, so assuming that you have not enough knowledge about the trig function, right? For example, how do I know cosine 0 equals to what? Sine 0 equals to what? For those of you who are familiar with this, your answers quickly, so you can fast forward a little bit. And for others who have been just not quite clear, I'm going to use the ART, okay, which I introduced in the other in the crash course. We explain to you, okay? So ARD, okay? So we know angles are measured, okay? So I'm going to bring this here, okay? I'm going to bring you, so we're going to learn how to evaluate the value, to evaluate sine 0 and cosine 0. Sine 0 and cosine 0. Sine 0, cosine 0. How do we decide that? Based on the definition, okay? Based on the ARD, okay? As I mentioned in my in my Trig review lesson, I said everything in trigonometry can be done either from A to D or D to A, right? So what do I mean by that? And I'm going to bring that coordinate here. Okay, I'm going to bring the coordinate here. So we're going to start the evaluation. We're going to start the evaluation. All right. So what kind of situation is this? Sine 0. 0 means the angle. Okay, so we measure angle which is 0. Okay, so that means the angle measurement, right? Angle measurement. We measuring 0. So when we measuring 0, we basically starting here, right? And ends here. Ends here. So this is the terminal. This is the terminal of angle 0. Okay, this is the terminal of angle 0. All right. Okay. Now, actually, if I move, that red line is going to shift. Okay. So so now you know. Okay. So by definition, okay, this angle is a special angle. So it's the terminal and the starting line is the same. All right. So how do we find sine value, cosine value, right? I'm going to bring the definition of sine and cosine here. Okay. Sine and cosine. Cosine. Okay, because that's what we need. Sine, cosine. Oh, no. Right here. Okay. Sine, cosine. Separated by a semicolon. You know what? Let me introduce a little table. So this will make it better organized. Okay, so cosine, sine. Okay, so we want to evaluate these two values. Okay, so how do we follow the definition to find those values? Okay, so be patient with me that especially you haven't learned trigonometry, right? In definition, so now we know the terminal. The terminal is the line that we start with, right? So the definition says x comma y is a point on the terminal side of the angle A. Our angle A is 0 other than the origin. So we're going to pick points arbitrarily, okay? It said x comma y is a point. It didn't require us to take, there's no requirement except that x and y cannot be 0. So we can pick any point. Okay, we can pick any point. All right, I can pick any point. I can pick a point here at 2. I can pick up a point at 3, right? Or 5, or any point, or maybe 5.7, right? I can pick any point. So this definition says you can pick any point on terminal side of the angle. So this is the terminal side of the angle, which is 0, right? So in our case, this is 0. This is 0, right? Suppose I pick up a point. Suppose I pick a point. I'm going to delete, clear this. I'm going to pick 1 point. Okay, I'm going to pick point at 3, 0. So this point I pick is obviously on the terminal side of the angle. That point is 3, 0. Okay, 3, 0. What does 3, 0 mean? 3 is the x, okay? Y is the 0. Okay, so let me write down. So x comma y. We have freedom to pick any point we want, except that the point cannot be 0, 0, right? So now I just pick arbitrarily 3, 0. For 3, 0, right? I guarantee that this condition is satisfied, so I'm going to find the R. Okay, so I'm going to find the R. So what will be the R? We know that x equals to 3, y equals to 0, R equals to square root x squared plus y squared. Okay, so x squared, 3 squared, y squared is 0 squared. So this is square root of 3 squared. So that's equals to 3. So R equals to 3. So R equals to 3. We're going to put it in place. And sine 0 is y over 3. Y is what? Y is 0. So 0 over 3. So sine 0 equals to 0. How about cosine 0? Cosine 0 is x over r. X in our case is 3. So 3 divided by 3 is equals to 1. You see, this is how we use ARD. So we started with A, right? A was 0 in our case. And in this case, actually, we don't have a reference angle. Reference angle is between 0 and 90 degrees, right? So our angle itself is 0, so it doesn't fit. But we can just go straight to the definition. So we pick any point. Okay, I assure you, if you pick point 5, 0, you still get the same value. Okay, go ahead and try that. Go ahead and try that. So this is how you can use the definition. You can use ARD to serve what you need in calculus, provided that you either have little knowledge of trigonometry or you have forgotten it, right? So this will serve you. This will serve you. Okay. All right. So now let's clean up. Let's clean up. Okay. So we got sine 0 equals to 0, cosine 0 equals to 1. So now we can plug in, okay? Cosine 0 equals to 1, sine 0 equals to 0. So finally, f of 0 equals to half. This is the y-intercept. This is the y-intercept, okay? So basically, the input is 0, the output is half. The input is 0, the output is half. Okay, we got our y-intercept. Okay. When you actually show your work, you don't need to show these to the reader. You really don't need to show what I just did to show to the reader. So you should be able to do it on your sketch paper to show these kind of work. Okay. And next, x-intercept. Okay, so after finding y-intercept, we're going to find x-intercept. For x-intercept, we may have multiple, okay? We may have multiple x-intercepts. Y-intercept, if we have it, we just have one, or none, okay? But x-intercept, how do we find x-intercept? To find x-intercept, of course, we're going to set the entire function equal to 0, right? So we set this equals to 0. When we set this equals to 0, and we ended up with solving this equation equals, well, this equation equals 0. 2 minus sine x is always positive, right? We studied that earlier. 2 times 2 plus sine x is always positive. We can multiply both sides by 2 plus sine x on both sides. Okay, we multiply by this positive number. And we will end up with cosine x equals to 0. All right? So now we need to find the value of x. We need to find the value of x. And what does this mean? This question, if finding sine 0, cosine 0 is a to t, we know cosine x equals 0. To find x, that's d to a. Okay, evaluate a sine 0, cosine 0. So I want to show you the comparison. Okay, sine 0, cosine 0, these are the angles are given where we use definition to find the ratio, right? So this is a to d, a to d. All right, but now what is the cosine? Cosine 0 equals cosine x equals 0 is that we know the ratio equals to 0. Okay, we know the ratio equals to 0. We know the d. And what are we looking for? We are looking for a. That's from d to a. From d to a. Okay, so this question is d to a. So from cosine x equals 0, what do we know? Right? Once again, we need to find the terminal, right? It's still the same definition, We're looking for, we're going to identify, we're going to pick any point on terminal side of the angle. So we're going to identify the terminal side of the, a point on terminal side of the angle. But from the definition, cosine x equals 0, if we use the x comma y r, and that definition is equals to r under x. Okay, x has been the point. Okay, so there's the point. So x comma y on the terminal side is on the terminal side of the angle. On the terminal side of the angle. Angle what? Angle x. Angle x. We don't know. Okay. So since r will never be 0, right? So 0, if we get a ratio equal to 0, that means r certainly cannot be 0. X has to be 0. X has to be 0. If x has to be 0, y cannot be 0, right? You can see from definition, right? From definition, r cannot be 0, so x must be 0. It must be 0. So the point we pick, how does the point we pick look like? It's 0, comma y, right? 0 because x has to be 0, right? So x has to be 0. The point we have is going to be looking like this. What kind of point is this? Well, those points are on the y-axis. So 0, comma y. Of course, because the point cannot be 0, since x is already 0, so y cannot be 0. Okay? Y cannot be 0. Okay, so we want to point it out. 0, comma 0. Okay, so this is D to A. It says D to A. All right, so let me just show you. So the points we're going to pick on y-axis. It cannot be the origin. So what point can we pick? We can pick any point. We can pick any point. So we can pick a point here, here, there, there. All of these points are on the terminal. That will cause the cosine angle equals to 0. Okay? That will cause the cosine angle. So what are the angles that terminate here? So what are the angles that terminate here? We're going to go back to the angle measurement. All the angles are measured starting from here. If we terminate on the y-axis in the positive direction, that's going to be pi over 2 or 90 degrees. If we measure from here, we terminate over here, that's 3 pi over 2, right? That's the terminal. And do we have any other choice where we can go clockwise, right? So these are the two terminals. On these, all these points on the two terminals, all the points on these two terminals, any point except the origin, they will lead to cosine x equals 0. So what are these angles? X basically represent angles. I'm sorry, this it's a little bit confusing. It's a little bit confusing here. Let me go back, use my red and blue. Okay, X in my lesson I use red and blue. Right, so this is red. Y is the blue. Blue. Okay, red, blue. So you understand what I'm saying? So it will not be confused with the X here. This X means angle. And so this is going to be the red. I'm sorry that that causes confusion. I basically assume you have watched my crash course on trigonometry. Okay. With that assumption, right, there's a red and blue. Red is horizontal, right? Meaning that you have any terminal, right? Any terminal, and this terminal is made red, so I don't like it. Okay. Suppose I'm going to choose the terminal. The terminal is going to be purple. Okay. And I pick any point on the terminal side of the angle, and then the horizontal measurement. Okay, the horizontal measurement. This piece is red. So by red is this the red I'm talking about? Okay. And the blue is this piece. This is the blue. Okay, so this star point on the purple is red, comma, blue. Okay, so the definition for cosine would be red divided by r, and r equals to red squared plus blue squared, and taken square root. All right. I hope I have made that clear. I hope I made that clear. So let me write it down. So in order not to be confused with the x here, which means it's the input for cosine, which means an angle, and we don't want to confuse this with our definition x comma y, so we call the x comma y red and blue. Okay, so red and blue. Blue, okay? And so r is equals to the square root of red squared plus blue squared. And the definition of cosine of angle x would be, okay, it would be the r under the red. Okay, so this will be consistent with our lessons Oops. Let's bring it back. Oh no. I'm sorry. This is going to be a little bit harder to get back to. But I think you got it. I think you got it, right? So let me clean this up. Let me clean this up. Right? So we found the terminal that will give us cosine of those, all of those angles that terminate either this way or that way will give us cosine of any of those angles equals 0. And those angles are, okay, those angle X are, and what are those angles? Those angles would be pi over 2, right? If we measure from here, we get pi over 2, 3 pi over 2, or negative pi over 2. So it's plus minus pi over 2, right? Plus minus 3 pi over 2. And this list continues. This list continues. So it's odd number multiples of, pi over 2. So 5 pi over 2. 5 pi over 2. Okay? So that's the solution to cosine x. We have many solutions. And especially the domain does not exclude any number. So at all of these points, we got x-intercepts. So if we are to list those x-intercepts, okay, if we are to list those x-intercepts, and so let me list those intercepts, right? When x equals 0, right? When x equals 0, no, wait. Excuse me. I'm sorry. When x equals to pi over 2, right? When x equals to pi over 2, we plug in here, okay? Excuse me. Oh, sorry. When pi over 2 is plugged in as the input, and this will be pi over 2, and that will be pi over 2. The numerator is 0, right? And so the whole thing is 0. Denominator is not 0. Denominator is always a positive. So this first x-intercept we express here is pi over 2 comma 0. And if it's negative pi over 2, well, this is going to be negative pi over 2. And this is going to be negative pi over 2. And it's still 0 because the cosine negative pi over 2 is 0. Okay. So another point, which is x-intercept, would be negative pi over 2 comma 0. So this list will keep going. Say if you have a negative 3 pi over 2, right? Negative 3 pi over 2, because the numerator is going to be the numerator is going to be 0, denominator is not, so you still get 0. So we have many x-intercepts. Okay, so those x-intercepts will look like these, and the list keeps going. Okay, so 3 pi over 2, negative 3 pi over 2, the list just keep going. But how do we express them overall, in general? The general expression would be the odd number multiples of pi over 2. The odd number multiples of pi over 2, right? 1 times, 3 times, 5 times. So the odd number multiples of 2k plus 1. 2k plus 1 is always the odd number. Pi over 2. So this is odd number multiples of pi over 2. comma 0. So all of these are the x-intercepts we're looking for. So I'm going to put this on the top. Okay. And k is any integer. K is any integer. K is any integer. Then your question would be, how much work do I need to show? How much work do I need to show? Okay. After you understand this whole process, when you show work for this step, you would just, you don't need to show me all these trigonometry stuff. You can just get here and remove all of these or just put them away. Okay, and then from here, you will come up with a solution that x equals to 2k plus 1 times pi over 2. That's the solution. And your x-intercepts would be like this. So you can show the x-intercept like that. So that's it. So you don't need to show all of these stuff. This is just my gift to you. Okay, my gift to you, how to do it from the definition. And in this case, obviously, this is D to A. Okay, so we can see A to D, D to A. Okay, so we did question B. Okay, so all of these, if you think out aloud, on sketch paper. That's my sketch paper. Okay, that's my sketch paper. And feel free to sketch whichever way you want. Okay, so all of these are sketch paper. All right. C, symmetry. Symmetry, the first thing you may like to check, the easiest thing to check is to check for even odd. Okay, sine function is odd, cosine function is even. Okay. I think we discussed that in our crash course, but you can also see it from the curve. Okay, you can also see it from the sine curve. So let me show you the sine curve. Okay, so this will also be think out loud. Okay, let me bring our function with us. Okay, bring our function with us. And now we come to C. Okay, and think out loud. Think out loud. Is a sine function, as we know, we have done the graph in our crash course. Okay, so sine x, if you graph it, right, so you get the graph pretty easily. How do we know it's odd? How do we know it's odd? Okay, odd function has this property, f of negative x equals to negative of f of x. What does this mean? What this mean is that when the input are opposite, their output are opposite too. Okay, for example, input. Okay, input is the angle, right? Input is angle. So suppose I have a input input 1 and input a -1, right? What's their output? Their output, sine output is blue, right? Is this piece. You can see when the green are opposite, the blue are opposite as well. So that shows that sine is odd. So this green-blue relationship is true for every input in the domain. Therefore, sine is odd. Sine is odd. All right, okay. How about cosine? Cosine is even. How do you see it? Cosine x. I'm going to graph it. Okay, cosine. What is even? Right? Sine is odd. Cosine is even. What's so special about even function? Even function is that when their inputs are opposite, their output are still the same. Opposite input produce the same output on this curve. Okay, on the look at the cosine curve here, right? Suppose I'm using green. Okay, green. Okay, that's input. That's input. They are opposite input. And what's their output? The cosine output is red. The red are the same height, same sign. Okay, that's even. And this is true everywhere for any input. Opposite input produces the same output. So that's even function. So as we know these functions, even the odd function, even function property, and what does that mean? Well, for cosine means even means the cosine of negative x. Cosine of negative x is equal to cosine x. Even, opposite input, same output. Sine of negative x, sine of negative x, and sine x, right? They are opposite. They're opposite. So if we put a negative sign in front of one, and we get the other. So that's the even odd relationship. Okay? When we decide on symmetry, one of the things is that, which is easy to check because you can see even function is symmetrical about y-axis. Odd function is symmetrical about the origin, right? So we can check if we have symmetry there. So you can check for f of negative x, what does that equal to, right? So f of negative x, and all the x replaced by negative x, right? What do we get? Well, cosine is even, so cosine negative x is cosine x, but here 2 plus sine of negative x is negative of sine x. So obviously this is not equal to f of x. These two are not equal, right? So this means it is not even. It is not even because you can see these two are not the same. These two are not the same. Denominators are not the same. Okay, so not even. Not even. So no symmetry about y-axis. Y-axis. Okay? About odd. For odd, we just have to compare f of negative x. We have f of negative x, which is here, of negative x, right? What is a negative of f of x? Right, we're going to compare these two. What does that equal to? Well, this is f of x. we put a negative sign in front of it. Are these two the same? Obviously not, right? So negative f of x is not the same as f of negative x. So they're not the same. So in this case, we will say not odd. So that means there's no symmetry about the origin. No symmetry about the origin. Okay. No symmetry. No symmetry. All right. Okay, so you can say, in the textbook it says there's no symmetry, but you have to do these due diligence to come up. Okay. Excuse me. In your work, you don't have to draw all of these. Okay, this is pretty much for your scratch paper. Asymptotes. Typically, we'll consider horizontal asymptote, vertical asymptote. Vertical asymptote, we have no place where there's no place that the function is not defined, right? So we don't have any vertical asymptote. Vertical asymptote happens typically there's a point of on the number line, there's certain places that's not defined, right? So in terms of asymptote, so we have no vertical asymptote. And first of all, you say no vertical asymptote, right? No vertical asymptote. Do we have horizontal asymptote? Did I bring the function here? Right. So when we take a limit, right? 1x approaching negative infinity, 1x approaching positive infinity, cosine x is bouncing between -1, +1. So this excuse me, there's no limit. There's no finite limit because it keeps fluctuating between it's up and down, up and down. So okay, so there's no asymptote, no horizontal asymptotes either. There's no horizontal asymptote. Okay. E, interval of increasing and decreasing. Intervals of increasing or decreasing. So we got the function. Oh, wait. Okay, I got the function here. And this is where we're going to find the, wait, what did I do? Okay, copy, paste. Sorry about that. Okay, so this is the place we're going to determine critical numbers, local max for the next step, local min for the next step is possible. So we're going to first determine the intervals of increasing or decreasing. Okay, so we're going to find the first order derivative. Quotient rule. Okay. And so 2 plus sine x squared differentiated cosine x, that's equals to negative sine x multiply, right? Subtracting, we're going to differentiate the denominator now. So we keep the cosine x, and we're differentiating the denominator, which will give us another cosine x. And then we're gonna simplify. We're gonna simplify. To simplify, cosine x times cosine x, that's cosine x squared. Okay, so it's really cosine x squared, but we shorthand write it as cosine squared. So these two are the same thing, okay? And here on this side, we're going to distribute. So negative sine x will time 2, right? Multiply by 2. Negative sine x will multiply sine x. So the outside parentheses will be removed. And this piece will certainly equals to negative 2 sine x. And sine x times negative sine x, that's going to be minus sine square x. Okay. Now we have learned a very famous identity, which is sine square x plus cosine square x equals to 1. So if we factored out the negative sign in these two, we will put them together, and that's going to be plus. And now in this case, we got this piece equals to 1. Okay? The negative sign can be factored out. And we're going to put a negative sign in the front. All right, you don't have to do that, but just make it easier. Okay, just make it easier. So now the first order derivative is found. The first order derivative is found. And what do we need it for? We need it to determine the interval of increasing and decreasing. Okay. And the denominator always positive, right? So it's the numerator and the negative sign, that altogether will determine whether the derivative is positive or negative. Okay, so first, let's set the first order derivative equals to 0. And this will lead us to that, negative number, when its negative sign is not useful here, so we're going to get the numerator must be 0. If the numerator must be 0, we got sine x equals to negative half. And we need to know x. So we're going to solve for x. X is the angle, right? The input for sine. So now we'll get to the d to a again. But this time, different from the one we did earlier, we have cosine x equals 0, but this time we have sine x equals to negative half. Still going back to the red and blue situation, right? The red and blue situation. Let me see. Well, we have these here, right? Angle measurement. So I'm going to still copy and paste all of these stuff. Right. There we go. I bring all of these for my sketch paper here. Okay. And I also have this piece over here. All right, so let's get started. How do we find all the axes such that sine of these axes is equals to negative half? X plays the role of the angle. Okay, angle measurement would apply. So we're trying to solve for x. We're solving for x from sine x equals to negative half. We're still going to use red and blue. So we pick a point. So from here, what do we get? Right? We know R is red squared plus blue squared and taken square root. So R is equals to, well, the sign is defined as, you know, blue divided by R. Okay, blue divided by R. R is always a positive. R is always a positive, right? So in our case, R is 2. And if R is 2, what is blue? Blue is what? The blue has to be -1. You see that? So we just really just apply the definition. So the question is, how many cases could there be that R equals 2, blue equals to -1? So if blue is -1, what is red? Right? So we have this relationship. We have this relationship that R squared, let me write it down this way. Okay. So R equals to, I'm just copy this piece, okay? R is equals to, and of course this piece X is red, and Y is blue, okay? We know blue equals to -1, right? So blue equals to -1. -1 squared is going to be 1. But we don't know what red equals to. We know R is 2. We know R is 2. So let's solve for red. Let's solve for red, right? So we're solving for red. So we square both sides. That's 2 squared is 4, right? 2 squared is 4 equals to the square root. And the red square, I'm just going to copy this whole thing here. Okay? And this piece is 1. I'm going to square both sides. I'm going to square both sides. Okay, so this is 4 equals to red squared plus 1. Red squared plus 1. Okay, subtract 1 on both sides. So red squared is equals to 3. What does red equal to? We're going to solve for red, right? So red squared equals to 3. I'm going to take the square root of red. So I'm getting square root of red. Okay, so let me change that to the color that we started with. Okay, it does matter because it helps. And what is red square taken square root? Well, that's going to be absolute value. Absolute value of red. Absolute value of red equals to √3. If absolute value of red equals to √3, what would red be? Well, red could be positive √3 or negative √3. So we have 2 different reds. We could have 2 different reds, right? But we know that every red, blue makes points on the terminal, right? So we have 2 situations. For the same blue, which is a -1, right? For the same blue -1, our work above showed there are 2 reds. There are 2 reds. One is √3, so there's a positive √3. Okay, and there's a negative √3. Okay, so there's a -1, there's a positive 1. So these are the 2 points could be on. So that tells us 2 different terminals, aren't they? So we got 2 different terminals. So we're going to plot these 2 points. We're going to plot these 2 points on our rectangular system. Okay. Oh, wait, sorry. Hold on. So this one will give us a terminal. That will give us a terminal. Okay. And this other one will also give us a terminal. And this will give us another terminal. This will give us another terminal. Okay, if I change the scale a little bit, I'm going to change the scale a little bit. Say -3, +3, -3, -3, +3. So these are the 2 terminals. So this process, let's look back. Okay, E, right? We get blue equals to -1, R equals 2. So D to A, so we're not at A yet, but we found a terminal. But we found a terminal where sine of those, all of those angles that terminates there, okay, all the angles that terminate here, some terminal here, some terminal there, and they will have the same sine ratio, which is -half. Okay. All right. So let's draw the red and blue. Let's draw the red and blue to confirm this. Okay. So we have red. Red will be positive negative √3, right? So we're going to draw the red. The red. That should be the red. One red. And there's another red. There's another red for the other terminal. Oh, wait. Oh, my bad. Red, thick. Okay, 2 red. The blue, how many blues do we have? We just have 1 blue. These 2 have the same blues. It's just 1 on each side. Okay, but they're both the same height of blue, the same value of blue. Okay, so this is going to be √3 comma 0 √3 half. -half, sorry. Blue is -half. So we're gonna have the blue marked and another one on the other side. So you can see for the same blue, wait a second. Oh, my bad. Because the blue is -1. I did something wrong there. Oh, I used half. I should have used 1. Sorry. I should have used 1. Okay. So because the blue is -1. Okay. The blue is, this is a -1. Okay. And this is a -1. My bad. Okay. All right. So you can see from -half, we derived red. We end up with 2 red, and we found the terminals. So now we're getting from D to A. D to A. And they each have a reference angle, right? They each have a reference angle. These 2 reference angles are indeed between 0 and pi/2. So now we are D to R, right, to R. And we are almost to A. D to A. We're almost there. And our A, of course, is the X, right? Our A is the input for sine, is the angles. But we already know the angles that terminates either here or there. So how many angles are there? How many angles are there? Of course, we have infinite. We have infinite many of them. Okay, because the domain is from all real numbers. Domain is all real numbers, right? So at this point, we're gonna have to do some more analysis. We're gonna do some more analysis because we're considering intervals of increasing and decreasing. Okay. So first identify these values that are on these terminal. So this angle, you see this the hypotenuse, look at this triangle, okay? The hypotenuse is 2, the blue is 1, right? So this is equal, this is if you, this is like this it's an equilateral triangle if, okay, I just want to refresh you. If we draw another blue, oh, sorry. Wait. Okay, so if I'm drawing another triangle on this side, okay, so forgive me for not having the color coordination. Okay, so suppose I'm drawing this triangle. This is blue, this red will be 2, this will be 1 plus 1, that's a 2. So this is equilateral triangle. So this is a pi over 6. And so if we measure clockwise, it's a negative pi over 6. And so we got the angles, right? So this reference angle is pi over 6 as well. But we also need to remember the angle measurement. The angle measurement for the input for the X is always either counterclockwise or clockwise measured from the same place, which is the green. All right, so let's see what we got. Okay, so if we measure, in this case, we want to measure counterclockwise consistently. Okay, we want to measure counterclockwise consistently, at least for a few situations. Okay, so we measure from here, counterclockwise. So over here, that's 7 pi over 2. Okay, so we got some X values. So those X values is 7 pi over 6. 7 pi over 6. How do I get 7 pi over 6? I just measure, and this is pi. Pi plus pi over 6 is 7 pi over 6. And continue to measure over here, we get to this angle. That's going to be 2 pi minus pi over 6. That's 11 pi over 6. Okay, 11 pi over 6 really is 2 pi, right? You measure 2 pi subtracting pi over 2, pi over 6. Okay, so that's 2 pi minus pi over 6. That's how we get 11 pi over 6. Okay. And how about 7 pi over 6? 7 pi over 6 is basically starting measure from here. That's a pi plus pi over 6, right? So it's a pi plus pi over 6. Got it? If that confuses you, okay, so this is 2 pi minus pi over 6. Okay? So with that, okay, so I'm gonna clean this up because we're gonna see the simpler ones. And there are many, many angles. So it basically goes around and round. Okay, it basically goes around and round. So next we're gonna look at an interval. We're gonna look at an interval. This interval, let's look at from whoops. We're gonna check for positive, basically the sign of the derivative, right? So we starting from, suppose we're starting from 7 pi over 6. Okay, 7 pi over 6, 11 pi over 6, of course we have more values. You just keep adding 2 pi. If this adds 2 pi, you get another one. Added 2 pi, you get another one, okay? There we go. Whoops, sorry. This piece is 11 pi over 6. Okay. We start measuring, say, from 0 to 7 pi over 6. From 0 to 7 pi over 6, what is the sign of the first order derivative? Okay, so what is the sign of that first order derivative? Okay, so that's the sign of the first order derivative. So how do we decide on that? You may like to pause and work on it yourself. Okay, we'll take a break. All right, here I'm going to show you how to use the picture, the basic picture of sine to determine what we need here. Okay. So I'm going to put the sine curve right underneath it. Okay. And because this is from 0 to 7 pi over 6, so I'm going to make adjustment of the sine curve. So it will be aligned with the positive. Okay. The other intervals can be, because they're periodic. Okay, they're periodic. And so here I'm going to put it as 7. Okay. How do we use it? How do we use this curve? Right? 7 pi over 6. 7 pi over 6 on the curve, we can find a point. Okay, so that's going to be 7 pi over 6. 7 pi over 6, comma 0, right? So I'm just going to identify the point that corresponds to 7 pi over 6 right here. Okay, so we're going to just scoot over a little bit. 7 pi over 6. The next one is 11 pi over 6. Okay, 11 pi over 6, comma 0, right? So that's another point right there. So 7 pi over 6, 11 pi over 6, we don't need this much here. And provided that this is from 0, right? So we can have this. Okay, so we have this lining up. So now how do we determine, because we're determining the sign for this piece, not the sign, right? We're going to use the basic sign function to determine that. And we have we have 2 points here, right? We have 2 points here, but these 2 points, how did we get these 2 points? We got these 2 points by setting, right? By setting 2 times sine x plus 1 equals to 0. So when we have it equal to 0. When we have it equal to 0, remember we solve for sine x, and that equals to -½ right? So that's how we found, the work we did above is just to get these two angles, right? Once we find these 2 angles, there are a lot of other angles. So that's just one case. Okay, that's just one case. The other case will be, what if it's less than 0? Because we want to determine, so let me make enough space. Okay, I'm gonna make enough space in case I need space, okay? The next one is that if 2 times sine x is less than 0, right? So that's the case 1 equal to 0, case 2 less than 0. And a case 3 will be greater than 0, of course. If the second case, right, if the second case less than 0, we're going to get sine x less than negative half. What does it mean, sine x less than negative half? Okay, see, for sine x equals to negative half, we can draw a horizontal line. Okay, negative half, and we will what color I'm gonna use? I'm gonna use red. Okay, so this is a red. This is for equal to negative half, we got the red, and the red will cross at 2 points. This point, okay, this point, and this point. And this point, the x coordinate, this point, okay, will be 7 pi over 6. And the y coordinate would be negative half. So let me mark it for you. Okay, I'm going to mark it for you. So you understand. So this when it's equal to negative half. Sorry about that. I need to make the curly. Okay, so this point is 7 pi over 6, comma, negative half. You see, I drew that red horizontal line, which is going to be, that was y equals to negative half. All right, and this point is 11 pi. So this is another way to determine the point. But you sometimes you still need especially you're not familiar, you're new to trigonometry, that you're not quite familiar with unit circle, you still need the way I showed you to find these values. Okay, especially the method I use there can find, it's a very general method. It's a very general method. So this just show you if it's less, if it's equals to negative half, right? But what if it's less than negative half? Less than negative half, it will be the red. We will be drawing these numbers, right? What are the case for a sine x less than negative half, right? If this is negative half, less than negative half would be, would be lines under, below the red one and above the negative one, right? For example, negative 3/4. Okay, negative 3/4 is less than negative half, right? So let me draw the red, right? So we have many cases less than negative half. So basically you have many red beneath the negative half, beneath the red, the highest red. So what are those angles? And those angles obviously is between 7 pi over 6 to 11 pi over 6, because all of these is above, right? So these values, okay, I'm going to mark it. All right, so let me draw 7 pi over 6. comma 0, comma 11 pi over 6, comma 0. All of these angles, okay, I'm going to show you with green thick. So all of these values, okay, let me clean this up. All of these angles, all of these input for x will cause sine x less than negative half. This, the top red is negative half. All the others, so all of these values will be the answer to sine x less than negative pi over 2. If 2 times sine x is negative, if this is negative, right? If this is negative, negative times negative, then the derivative is going to be what? Positive. Positive. So on this interval, the derivative is what? Positive. Positive. Okay? How about 2 times sine x plus 1 greater than 0? Then we will get sine x will be greater than, sine x will be greater than negative half. Right? If sine x is, if the 2 times sine x is greater than 0, so what are those? Those are all of the other reds. Okay, so those other reds would be like, you know, this is a negative half, right? And all of these, oops, sorry. I'm going to use a red line. Right, so all of these reds, right? Keep going. All of these reds certainly is above negative half. The output is larger than negative half. So I have many of them, and those other places would just be, especially when 2 times sine x plus 1 is positive. Okay, it's a positive. In those cases, if this is a positive, denominator is positive, we have a negative sign there, so all of these would be negative. And here, of course, is 0, right? And here is 0, and these will be negative. We have many intervals. We have many intervals with such a situation. Okay? And periodically, okay? So say from 0 to 7 pi over 6, this is a negative. So decreasing, increasing. Decreasing, increasing. So we have a local minimum. And this piece is increasing, decreasing. So we have a local max. Okay. So this will be a local min. And this will be a local max. Okay, so of course, that's for the next question. So let's see how we answer that question about increasing, decreasing. Okay, so here, we're going to put this away. So f of x, oops, sorry, decreases in the interval of 0 to 7 pi over 6. Okay, and also decreases in the other interval from 11 pi over 6 to 2 pi, for example, or to the next one, okay? This will be 11 pi over 6. There will be, if we add 7 pi over 6, if we add 7 pi over 6 with 2 pi, but if we only look at the interval from 0 to 2 pi, of course, it's much smaller. So now we just look at this. Suppose we look at the interval just with just 2 pi period. Okay. So on these two intervals, from 0 to 7 pi over 6 to 11 pi over 6, that's going to be decreasing, increases, f of x increases in the interval of 11 pi, 11 pi over 6 and 7 pi over 6 to 11 pi over 6. Okay, we put a smaller number on the left. But because the function is periodic, okay? So right now, we have not considered the entire number line. We're considering basically from 0 to 2 pi. Okay, we're gonna come back to it. The next part is local max, local min, right? Local max, local min, local max, local min at 11 pi over 6. Whoops. I'm sorry, 7 pi over 6. Okay, local max is 11 pi over 6. Okay. What are the value? So let me bring function f with us. Okay, we'll bring the function with us. And we're going to evaluate the local min, local max. 7 pi over 6, that's a local min. Local min. Okay. What do we get here? And this other one is 11 pi over 6. 11 pi over 6. And now we're going to have to evaluate all of these from ARD. Okay. So I'm going to show you once again by definition. Okay, so this is a local max at, all right? All we have to do to determine local max, local min, we just have to determine what is a cosine 7 pi over 6 and what is sine 7 pi over 6. Okay? We just did the work on this piece, right? And we got those numbers. So I'm going to bring this over. So now this time it's going to be ARD. Okay, so I'm going to put it here for our convenience. All right, when we need any number, we know that the blue is -1, the red is √3. Okay, -1. So we have the points, right? We have the points right there. Okay, so we got it. So sine 7 pi over 6, we already know, right? We already know those are -half. So we know that, right? We already know this piece is -half. We already know this is -half. But what is a cosine 7 pi over 6? Cosine 7 pi over 6, which is this terminal, is the red divided by r, right? the red is √3, and we got a negative √3, negative √3 divided by r is 2, right? So because in this picture, we just recall what we got, right? So r equals to 2, the red equals to √3, positive or negative √3, okay, depending on which terminal. And the blue equals to negative 1, I'm sorry. Blue is negative 1. Did I plug a number in correctly? Yeah, I think we got it. Okay, we got it. And we just simplify this piece. What do we get for simplifying this piece? The bottom is going to be, so let's just take our time to do this. You can do it, okay? You can totally do this, right? So this is going to be 2/3, 3/2, not 2/3, sorry. And then in the end, it equals to the 2 and 2 reduce, so we get a negative √3 over 3. Negative √3 over 3. And how about this piece? This piece, right? It will be this other terminal. It will be other terminal. And this piece this is still negative half. Okay, this is still negative half. We've done that, right? Because solving from negative half, we got 2 angles, right? We got these 2 terminals. Okay, that's the negative half. All right, so how about cosine? Cosine will be the red over r, right? Will be the red over r. The red this time is a positive √3 and r is 2. Okay, the other one was negative because it was the terminal in the 3rd quadrant. And this one is in the 4th quadrant. The red is a positive. In the 3rd quadrant, the red is negative. But anyway, so we got almost the same, except we don't have the negative. So we got √3 over 3. Local max, local min. This is a local max. This is a local min. I know this is this may be pretty overwhelming for a lot of you guys. It really calls for your knowledge in trigonometry. The point I'm trying to make here is I'm trying to tell you that with the introduction, with the crash course I have given you, if you focus on that, it will actually resolve all of these issues for you, okay? That's what I'm trying to show you. But, actual application for you, it may not be that easy, especially when you're doing this for the first time, all right? For those of you with adequate trigonometry background, this may not be that difficult, but still, you need to know A to D, D to A, all right? However you call it. Concavity, okay? So we got function, we got derivative. So now we're going to find the derivative of the 1st order derivative. So we're going to have to find the 2nd order derivative. Wow, let's go. Okay, let's go. So 2nd order derivative equals to quotient rule again. So the denominator was here, and then it's going to be power 4. What I'm going to do is I'm going to leave out the negative sign outside. Okay, so I'm just taking derivative of this piece. You guys follow me? So I'm applying quotient rule with that piece. So the negative sign, just leave it out. I'm differentiating this piece, that's going to be 2 times cosine x, multiply the denominator, which is something squared, subtracting this time, I'm going to keep the numerator, differentiate the denominator, which we're gonna get, differentiate this piece, that's gonna be 2. So 2 times the parentheses, and differentiate inside the parentheses, we get cosine x. Okay. This time it calls for our algebraic and trigonometry simplification skill. All right, so just follow me very carefully. So I'm basically copy and paste, but I'm going to do some modification here. So this 2, I'm going to put the 2 in the front. You can actually FOIL this, forcefully FOIL this. You're going to get a lot of terms. You're going to get lots of terms. I am, on the other hand, I try to simplify this. Because I see common factors. So I put everything in bracket, right? I'm going to take out the common factors one by one. 2 is a common factor, so there's a 2 on each, right? So 2 is going to be factored out. Okay, cosine x is a common factor. Cosine x is a common factor, so I'm going to factor that out. 2 plus sine x is a common factor. And we have a squared, and we have just 1 of it. So these are going to be factored out. There. Oops. 2 plus sine x. I'm sorry. 2 plus sine x. 2 plus sine x. Now it's a bit easier to simplify the inside. Okay, so we have 2 plus sine x. And open up the parentheses on this one, so this is subtract 1. Okay. So 2 minus 1, that's going to be positive 1. And plus sine x minus 2 sine x, so this is minus sine x. So we got that. There. What else can we do to simplify this? Wow, look at that. We have 2 plus sine x. We have 2 plus sine x to the power 4. So that guy is going to take away the power, one of the, the factors. So we got the power 3. And now we have come to this point. We're going to decide the sign of the second order derivative, which will tell us the concavity. Denominator is always a positive. We have a negative sign in front. 1 minus sine x, that's always positive. Because we know, right? Once again, I wish to mention that useful but yet sometimes neglected fact. You see, sine x is less than or equals to 1, right? So 1 minus sine x is always greater than or equal to 0. The smallest it can be is 0, so it's always positive. Okay, unless sometimes it's 0, okay? So this is a positive, denominator is positive, so our sign is determined by cosine and then by negative cosine. So when cosine is negative, there's another negative, so the second order derivative will be positive, right? So this will call us, one will be cosine be negative, one will cosine be positive. You know what I mean? So let me reorganize the term in such a way so we can see Okay, so we have a negative cosine x multiply. I'm going to put it in this way, 2 times 1 minus sine x divided by the whole of that. There. Okay, so I separated cosine x. I basically pull cosine x outside. Okay, so 2 times 1 minus sine x. This is, so the whole thing here, this is a positive. This thing is positive. So when cosine x is negative, second order derivative is positive. When cosine x is positive, second order derivative is negative. Okay, concave down, concave up, concave down. So how do we use that cosine property, right? So I'm going to bring that cosine curve we did earlier, cosine curve. So understand our issue here. So this is my cosine curve. We can use our cosine curve. So we're going to look at the interval from 0 to 2 pi. Okay, we just look at one period. So 0 to 7 approximately. Okay, so this is 0, this is 2 pi, 6 point something, right? So I'm going to mark these 2 points. So we're going to look at the 2 pi comma 0, right? So there's a point right there. So we look at the interval from here, 0 to 2 pi to 2 pi. So this is the interval we're looking at. One cosine is positive. Cosine is positive at, this is a pi over 2, this is 3 pi over 2. Okay? So from pi over 2, see, from here, from 0, right? So this piece is pi over 2. Pi over 2, comma 0, dot, sorry, red. Another one, 3 pi over 2. So this is 0, this is a 2 pi, pi over 2, 3 pi over 2, okay? And that's a 0. We're just looking at this one period, right? 2 pi over 2. Let's draw a number line. Okay, so that's, oops, there. So over here, that's 0. Okay, this piece here is pi over 2. Oops, sorry, 2 under pi. Sorry. And this other one is 3 pi over 2. 3 pi. 3 pi over 2. You see, from 0 to pi over 2, cosine is positive. Cosine is positive, negative. So this, in this interval, second order derivative is negative. Okay? Of course, at pi over 2, that's 0. Between pi over 2 and 3 pi over 2, cosine is negative. See, this curve is negative. If this piece is negative, negative, negative is positive, right? So boom, 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 that's positive. And over here is going to be 0 again. Okay. Above 3 pi over 2 to 2 pi, this one cosine is positive and continue to be positive in that case. And the second order derivative is going to be negative. So in terms of concavity, right? So this function, the function is a concave down, concave down, okay? And the function in the middle is a concave up. And in this piece is concave down. All right, so that's how do we utilize the basic curve to serve our purpose, okay? I hope this demonstration may help you. I have no intention to confuse you whatsoever, but it is a lot. I know it is a lot, okay? Especially you know, put all of these things with trigonometry all together, right? And that's a lot of information. So you have to really allow yourself some time to understand. All right, so we got concavity there. Do we got inflection points? Inflection points. Obviously, we got inflection points because at pi over 2, there's a change of, concavity. As 3 pi over 2, there's also a change of concavity. So inflection points are pi over 2, 3 pi over 2. And of course, we know this pattern will continue. This pattern will continue, right? So 2 pi plus another 2 pi will get another concavity point. So if we keep adding 2 pi, right? If we add 2 pi, if we keep adding 2 pi, we get more. Okay, so this is just a picture between 0 to 2 pi, right? So this is just a period, and we have many periods of 0 to 2 pi. So this pattern will continue. So finally, that's to sketch the curve. Finally. Okay, that's finally, we got to sketch the curve. I'm just going to, I know it's time. It's been pretty long for you as well, okay? So when we graph this picture, actually there are lots of periodic things happening. Okay, so I'm going to show you some, maybe this will make it 15, right? You can see the picture is a periodic one. Okay, so we have periodic function here, and this was just a continue. So what we did here, we did is just this period. We did this piece, and there will be another piece to each side. So we have infinite many pieces. To mark some points that make sense that we have done. Okay, to mark some points, for example. Okay, to mark some points. So where would it be the local max, local min, right? Where is our local max, local min? We have local max, a local min at 7 pi over 6, right? So that point is 7 pi over 6, that's the input, and the output is negative √3 over 3. If I am to plot this point on the picture, you shall see that. I'm going to make a red dot. Local min, local max, right? Local max is at a point where we have 11 pi over 6. That's the input. The output is √3 over 3. So if I plot this point in the picture, and we shall see it. And that's, let's make it a red dot. That's the highest point. That's the highest point. Okay, so we have many local min, many local max. And we also realize these local max, local min, they are also absolute max and absolute min. We have many absolute max and many absolute min. Okay. We also realize we have absolute max and absolute minimum. Okay, so the local max, local min are also absolute max, absolute min. All right, so let's put it over here. And we have many such points. That's the interesting part, okay? So the absolute max, absolute min. So absolute max, that's absolute max. Okay, absolute min, absolute min. Here we go, right? So how many do we have? How many do we have? How many absolute max, absolute min do we have? So from this local min to that place, how much is the difference? Well, the difference is 2 pi. Okay, so this is the local min, right? If I add this point, just plus 2 pi. Just plus 2 pi, we're going to get another lowest point. And max, if I add another 2 pi to the input, I will get another max. And if I subtract 2 pi, I will get to here. And I just keep moving. If I subtract this one by 2 pi, I'll get there. Okay, so let me show you. See if I subtract 2 pi. Subtract 2 pi. Let me wait. Max min. We should go there. Okay. Did I subtract 2 pi? It should go there. Oh, never mind, because I forgot to make the dots. Okay, you can see it goes there. But this one, if I subtract 2 pi, it's going to go there. So adding 2 pi, subtracting 2 pi, right? So we will get new ones. So subtract 2 pi. All right, guys, that's a lot of contents. But if you can pull through this, right, go make sure you understand this, really understand this by studying it over and over, you will have a much improved knowledge about trigonometry as well as this curve sketching. But you know, try the best you can. That's all we can hope for. Thank you for watching.